We're now going to look at the topic of integration. Integration essentially asks the question, if this is the derived function, what did I start with? Now before we can answer that, we need to observe the following. Here are three different functions. If I differentiate these functions, what do I get? Well, x cubed differentiates to 3x squared. X cubed plus 7 will differentiate to 3x squared. And x cubed plus minus 3 will differentiate to, 3x squared. So three different functions here have differentiated to give the same derived function. Now this gives us a bit of a problem, but one that we should expect, because constants obviously differentiate to 0. So if we're to go back the other way, we're to expect a constant. So this we refer to as our constant of integration, and we need to make sure that we always write our constant of integration at the end of our equation. So what do we know about? We know that we're going to have this constant of integration for sure. When we differentiate, we would reduce the power of x by 1. So to integrate, to go back the other way, we're going to increase the power of x by 1, which is going to make it x cubed. Now that's going to cause me a problem, because we know that if I differentiate x cubed, what do I end up with? Well, I end up with 3x squared, and I didn't want 3x squared, I just wanted x squared. So I need to make a correction, and that correction is to divide by 3, or divide by the new power. How do I write this down? So notation that we use for integration looks like this. A sort of elongated s, x squared dx, and I would read this as integrate x squared with respect to x. We will come on to a point, hopefully later in your mathematics career, where you integrate with respect to other values, but for the time being, we'll just leave it at integrating with respect to x. Now, in doing this, what do we end up with? We end up with 1/3 of x cubed plus our constant of integration. What's our rule? Well, if we're to integrate any polynomial, we know that we would write that down as x to the power of n with respect to x. What do we get? The first thing that we do is we raise the power by 1. Then we make our correction, and we never forget our constant of integration. Let's now apply this rule several times over. Here we're going to integrate a polynomial, and we're going to go through and integrate term by term using our rule. So we increase the power by 1 and then make our correction, with the original coefficient being 4. The next one, we're going to increase the power by 1, make the correction with the original coefficient being 2. Next, this is really x to the power of 1, so if I increase the power by 1 and make the correction, I end up with this. And then finally, there's no x here. Well, I could imagine that as being x to the power of 0. If I was to increase that by 1, that would become x to the power of 1, and then make my correction, and then never forget my constant of integration. Tidying that up, that becomes x to the power of 4 plus 2/3 of x cubed plus 1/2 of x squared minus 3x plus constant of integration. If I get introduced to fractions, the first thing I'm going to do is to say this is really just the integral of x to the power of minus 2 with respect to x, single powers of x, all on one line. Now I can apply the same rule. I increase the power by 1, which becomes minus 1. I divide by minus 1, I make my correction. The original coefficient here was 1, and never forget my constant of integration. So this becomes minus x to the power of minus 1 plus c. Or another way of writing that down would be to say minus 1 over x plus c. And that's a very basic introduction to integration.